Good day, grade 12 learners. Welcome to today's mathematics lesson. My name is Annelen Sindane. This lesson is brought to you by Gauteng Department of Education in collaboration with Saibono Discovery Center and broadcast by Pagama Research and Development. Our lesson for today, it's under functions and graphs, and we are going to look at the sketching of our algebraic graphs from grade 10 and 11 and part of 12. At the end of the lesson, we should be able to determine the general and sketch the general equation and sketch the graphs for the linear, quadratic, hyperbolic, and exponential functions. we should be able to revise the effect of the parameters A and Q and understand the effect of P on the graphs of the functions defined by the first one. It's our parabola. We also have our linear graph, and then we have our hyperbolic graph, and we also have our exponential function. Now, you can refer to the CAPS document as well as the examination guidelines for grade 12 for more information. Now, for our knowledge, we should have the grade 10 and 11 information on functions. We should be knowing our number systems, our algebraic equations, and algebraic expressions, substitution, factorization, and so on. Now, we will look at the function notation. We know that if we are given a function y is equal to x minus 2, that's a function of x in terms of, or the function of y in terms of x. We know that y depends on x. So our y is a dependent variable, and we know that y becomes our independent, it's our dependent variable, and x is our independent variable. We always give those as ordered pairs in terms of coordinates in the Cartesian plane, where we have our x first and our y value coming after the semicolon. Now, we have y is equal to x minus 2. We will concentrate more on the sketching of our graphs. We know how to get our x and y intercepts. We know that for us to get our y-intercept, we will say our y is equal to, we let our x be 0, and then we'll have 0 minus 2, and we get our y as negative 2. And the coordinates of the y-intercept become 0 and negative 2. To get our x-intercept, we let y to be equal to 0, and then we solve the equation x minus 2 is equal to 0, and we get our y as 2. Now, from there, we know that the coordinates of the y-intercept become 0 and 2. So we will have the coordinates there. To help us sketch the graph, because there's a difference between drawing and sketching, in our exam, we are expected to sketch the graphs, not to draw. I know we're using the table format, but for now, I would want us to use our parameters to help us sketch the graphs. So we know that our gradient, which is we know that our linear function is normally given as a times x plus q. So if our a is positive, we know that our gradient is going to be positive. So it means we will have an increasing function like that. So we can easily sketch our graph like that, and we have our f of x. So as well, we are also going to learn about the functional notation as we move along, where we are moving from y to introduce f of x. This is interpreted as our function of x is equal to 2x minus 3. So this is our function in terms of x. And we know that for us to get the y value, whatever we want to get, in place of x, we will substitute a value. Whatever we get as the output gives us our y value. And we would say, for example, if our x is 2, we will say f of 2 will be equal to 2x minus 3. That is the correct way of doing it. There is an example. We are given f of x as 2x minus 3. we want to evaluate f of -1. So where there is x, we'll substitute -1, and we will get our value as -2 minus 3, and that gives us -5. So we are able to find the coordinates of that point as our x is -1 and our y is -5. So the coordinates of the point will be given by -1 and -5, because our x value is -1 and our y value is going to be -5. The definition of a function. I know in grade 12, we change the definition of a function and say a function is a relationship where for every x value, there is only one y value. The other functions that we call functions, we call them relations in mathematical language. A parabola, for example, we know that sometimes when you substitute your x values, you might get the same y value, and we call that a many-to-one function. And mathematically, that becomes a relation and not a function, because by definition, a function, it's when you have an x value mapping to a single y value. This is the example that I will give. We will have our domain, and we also have our range. Diagrammatically represented, it means I will have my x values this side and the range becomes my y values. So if I have a -1 here, it means it might map to only one y value here, which I'll call y1. If I have a 0 here, it will map to one y value, which I will call y2. And then if I have an x3 here, it must map to a single y value that I'll call y3. So mathematically, a function has to be one-on-one for us to name it a function. Otherwise, it's a relation. I know we have a many-to-one function, a one-to-many function, and we will deal with the definition of a function as we do our inverses. Now, we have our mother functions I've mentioned. A linear function, we have y is equal to x, which passes through the origin, and it will have a shape like that. Its domain will be x is an element of real numbers, and the range becomes y is an element of real numbers. A quadratic function, also known as a parabola, an example is y is equal to x squared. We must know the basic function of these original functions. Now, a parabola has a turning point, and it has an axis of symmetry, and to get our shape, we know that it can either be concave up or concave down. You will see this as we move along. But again, the domain, its x is an element of real numbers unless it has a restricted domain. Our range, for this original graph of x squared, it will be y is greater than or equal to 0. And then we have the reciprocal, also known as the hyperbola, given by y is equal to 1 over x. Now, this will have two curves, and we introduce another concept of asymptotes. Where the graph is not defined, the graph will get as close as possible, but it will not intersect our asymptotes. We have seen this in the previous grades. The domain, it excludes the line x is equal to 0 because that's our y-axis. and x is an element of real numbers, but we exclude x is equal to 0 because that becomes an asymptote. We cannot have y, we cannot have this. Any number divided by 0 becomes undefined, hence that becomes an asymptote. X equals to 0 becomes an asymptote. As well as if we are going to have, if we want to get our x-intercept, remember we said to get our x-intercept, we let our y be 0, we'll have 1 over x, and when you multiply there, you end up having 0 is equal to 1, which is not mathematically correct. Hence, our asymptotes are when we have our x and our y axis, because our y is equal to 0 on our x axis and x is equal to 0 on our y axis. We move on now to our exponential function. Here we are using exponents and our x is on the exponent and our b becomes our base. Now, when you look at our exponential function, we can have a base as a whole number or a fraction which is greater than 1. And we will have our function having the curve that we are seeing there, and we call it an increasing function. And the domain from negative infinity to positive infinity, and our range, we exclude the asymptote. It has to be greater than y is greater than 0, as our graph will not have an x-intercept. When our base is a fraction between 0 and 1, you will realize that our function becomes decreasing. The domain and the range will be given by the values that you see on the PowerPoint there. We shall move on now to sketching a function. Now, we should be able to determine the shape from our value of a in our function. Remember, we are dealing with the 4 basic functions. F of x is equal to ax plus q. We also have f of x as a bracket x plus p squared plus q. And we also have f of x is given by a over x plus p plus q, which is our hyperbola. And we also have our f of x given as a times b to the power x plus p, and then we say plus q. We should be able to determine the shape of our graphs, and we should be able to sketch from there. Please note that using the table is advisable, but sometimes it takes a lot of our time, so we should find a way of sketching our graphs quicker, because we just need our intercepts, we need our turning points. If it has a turning point, we need our asymptotes, then we get the general shape, because normally sketching a function is normally 3 marks, so we don't need to take a lot of time there. Now, we determine our shape from the value of a. We also determine our y-intercept. We are also able to determine the vertical shift using the value of q. And we are also able to determine our horizontal shifts by looking at the value of p. These are important points that you must note. To get your x-intercept, you let f of x or g of x, remember, that's for naming purposes only. Any letter of the alphabet can be used to name our functions. So it shouldn't always be f of x. Sometimes it can be k of x, so we should be careful about that. We just let our y be 0, then we are able to get the x values, which we sometimes call our roots. To get our y-intercept, we let our x be 0, because we know that along the y-axis, our x is 0. And then the turning points, for example, our parabola has a turning point. To get the equation of the turning point, we use the coordinates of the point negative p and q to help us get the coordinates of the turning point on our quadratic formula. And also remember, we also use x is equal to negative b over 2a. You shall see this as we move along. And we can also use, if we are given the x-intercepts, you add the two x-intercepts, you divide them by 2. It will give us the x value at the turning point, and from there we can substitute back to our function to get the corresponding y value at the turning point. We move on. If you need any other point, you choose any x value that you can substitute, and then it will give you another point on your graph. Now, we should show our asymptotes as dotted lines. We shouldn't make them bold. And also sometimes we'll be required to show the axis of symmetry, and we use dotted lines to represent those. You will see as we move along. Now, most questions sometimes will ask us to determine the equation after doing some transformations. We know the reflections, we should be able to reflect the graph about the x and about the y-axis. And we should also note that the y-axis and the x values change their signs. You should be able to see that as you reflect about the given axis, you will see as we move along. And we also reflect about the line y is equal to x. That one, we give it a special name, because if you have f of x and you reflect f of x about the line y is equal to x, you get the inverse of f of x. Now, linear functions. This is revision. I will ask you to quickly determine the x and the y-intercept. 2 minutes, you should be done, and then we will sketch the graph. Right. Welcome back. I know this was very easy. To get our y-intercept for the graph of f of x, we will just say f of 0, And where there's x, we put 0, we know that we'll get -8. So meaning our y-intercept will be 0 and -8. To get our x-intercept, we are solving the equation 0 is equal to 2x minus 8, and this will give us 2x is 8, and we get our x as 4, meaning our x-intercept will be 4 and 0. For g of x, we will do the same, and we got the following values. Now, we need to sketch the graph on the same set of axes. Let me go back a bit. Yes, I calculated the x and the y-intercept of f of x. For g of x, we are going to do the same thing. G of 0 becomes 0. G of 0, it means we are going to put -2 times 0 plus 8, and this will give us 8, meaning our y-intercept will be 0 and 8, and to find our x-intercept, -2x plus 8 will be equal to 0, and we get our -2x as -8, and we get our x as 4, giving us our x-intercept as 4 and 0. The next step, we are supposed to sketch. As I have indicated, I'm able to straight away for f of x, I transfer my intercepts, it's 0 and -8. My x-intercept, it's 4 and 0. I just indicate it there. If I check, the gradient of my f of x is positive, meaning my graph is increasing, and I will have that as my f of x. Then I also indicate my y-intercept for the graph of g. I also indicate my x-intercept for the graph of g, and then I draw my graph of g of x. Because the gradient is negative, I'll just join the 2 points from the y-intercept to the x-intercept, and then I extend my line to get the graph of g of x and f of x. Now, this means for your x-intercept and y-intercept, it's normally 1, 1 for a linear graph, and then the shape, you get the 3rd mark. So it will be 3, 3, and you get those 6 marks if the examiner is lenient. Part C, we are supposed to indicate if f is a decreasing or increasing function. We give a reason for your answer. F of x becomes increasing. As your x values are increasing, your y values are also increasing, and it has a positive gradient. You can use that as your reason for either increasing or decreasing. Hence, f of x is said to be an increasing function. As x values are increasing, the y values are also increasing. We move on to the next one. Write down the domain and the range for the graph of g. Now, if you look at these functions, at the end, I've tailed them with arrows to show that this function increases to infinity or decreases to -infinity. So, your domain, remember when you talk of domain, you're talking about the x values. Our x values are down here, the number line. And we know that it starts from -infinity up to +infinity. So if you look at that graph, we don't know where it starts and we don't know where it ends. So I can just say the domain is x is an element of real numbers, or I use the notation x is an element from negative infinity to positive infinity. We have to be careful here when we are using the interval notation. Infinity is not known, hence we use the curly brackets, not the square brackets. The range, we shall have the range y element of real numbers, because also we don't know where it starts and we don't know where it ends. Or if we are using the interval notation, y will be an element from negative infinity to positive infinity, like that. And then we move on. These are the things that we will discover and we shall use whenever we are using we are sketching a linear function. If our q is greater than 0, we are given f of x is equal to ax plus q. Like as we have seen in the previous question, if a is greater than 0, we know that it's positive. It means it's an increasing function. And if our q is greater than 0, it means our y-intercept will be 0 and q. And the x-intercept will be a negative value there. And we know that if we solve this algebraically, we'll get ax is equal to negative q, and our x-intercept becomes negative q over a, depending on the value of a. So we can say the coordinates of that point will become negative q over a and 0, like that. We can do it for all the graphs, but as you can see, I've illustrated with one. You are able to follow the remaining ones. If our a is less than 0, we have seen from the graph of g, it's a decreasing function. And in this case, because our q is positive, our y-intercept will be on the positive side and our x-intercept will be on the positive side, as you can see there. And then if our a is equal to 0, that's the equation of a horizontal line. And we normally give the equation as y is equal to q, or f of x is equal to q. If we have a vertical line, the gradient of a vertical line is undefined. Hence, the equation will be given by x is equal to k, or f of x is equal to k. That's the equation of a vertical line. And then if q is less than 0, you are able to see that it will have a y-intercept on the negative side. If it's increasing, also if it is a decreasing function. Also, our horizontal line will have the equation as f of x is equal to negative q. Now, we have talked about the third part. You are able to see that that one gives us the original graph of f of x is equal to x. And the other one, it's a decreasing function, which is f of x is negative x. It will give us those values. And our domain and range, you are able to see how we are going to obtain them, because these questions are asked in the exam. Now, we are going to look at the next 3 functions where we are saying we should be able to look at the transformations based on the original function, which is our mother function. M there represents the mother function. X plus P, we said it affects our horizontal transformation. And we know that Q affects our upward and downward movement. We should be able to recognize these from the equations of our functions. We will move along and see what happens when that happens. And we are having the 3, parabola, hyperbola, and the exponential function. Now, from the above linear function, we have said A determines whether our function is increasing or decreasing. But for the next function, you will find out that A represents something else. As you can see, A will always affect orientation. P will always affect the shift to the left or to the right from the original y-axis. And then you are able to see that, and I have given an illustration there. We shall move on. Q, as I said, affects the vertical movement, up and down movement. So if Q is greater than 0, the graph shifts up. If Q is less than 0, the graph shifts down. There is a note there at the bottom. If you are having the shifts in both A and Q changing, the effect of A must be realized first, and then the graph is either stretched or reflected before it's shifted vertically. You will see as we answer the questions. I will quickly talk about the characteristics of our parabola or quadratic function. The parabola, we have three forms of the equation. You can have y is equal to ax squared plus bx plus c. We call that one the quadratic form. Y is equal to a bracket x plus p squared plus q. We call this one the turning point form. And we also have y is equal to a x minus x1, x minus x2. And we call this one the intercept form. In most cases, for the third form, it's either you are given the information about the graph, x-intercept, and one other point, or the graph is sketched and then you are supposed to determine the equation. Now, let's look at the effect of the parameters. Our parameter A affects the shape. If our A is positive, our graph will be concave up. I know at some stage we're using smiley or sad, but for our purposes, because we need to use the correct mathematical language as we move along, I will use concave up. It will also assist us when we do topics like calculus that we are going to do next. Now, if you check, if our A is positive, it means our graph decreases up to the turning point, and then it starts to increase as indicated by those arrows. Now, how do we know that the graph is decreasing or increasing? We have been taught these methods. You can find the average gradient between any 2 points. You will find out that it's negative. And our function will be decreasing. We normally also indicate this using the negative sign, and when it's increasing, we use the positive sign there. And then axes of symmetry, we will show you how to get them. If our graph is concave down, you will realize that our graph will face downwards. Please remove that up there. It is concave down. If our A is less than 0, it will be concave down. Let's fix that. A less than 0, the graph is concave down. It means it's facing downwards. It will therefore increase up to the turning point, then it will start to decrease after the turning point like that. You will see as indicated by the arrows there. So we move on. These are the characteristics, and then you are able to see the positive value of A increases, and you know that the graph will either be compressed or it will stretch. You will see that as you sketch the graph. And we know that if our A is greater than 0, as I said, it will be concave up. Q becomes our minimum, and we know that Q is the Y value at the turning point. If A is less than 0, our parabola is concave down, and we are saying Q becomes the maximum for that particular function. We move on now and say, for us to be able to sketch our parabola function, we should be able to get the coordinates of the turning point. And we know if it's a turning point form, that one, the coordinates of the turning point will be negative P and Q. And we also know that if we are using these other ones I've illustrated, I said to get the turning point, we will use X is equal to negative B over 2A. We get the X value at the turning point, which is also the equation of the axis of symmetry. And then from there, to get the coordinates of the turning point, it will be negative B over 2A and F of negative B over 2A, something like that. And then if we are using the third form of our equation, so this one goes with the quadratic form. And then here we are able to get, we add our x1 to our x2, divide them by 2. Whatever we get as the x value here, we take it and substitute it to the original function to get the corresponding y value at the turning point. The equation of the axis of symmetry divides the graph into two equal parts. Like I said, if our a is positive, it would mean our graph is concave up, our function will decrease up to the turning point, then it will start to increase like that. We move on. The domain for our quadratic functions, mostly there are no restrictions, but you will find restrictions when it comes to our inverse function of a parabola. The range also depends on the value of our q and also the shape of our graph. If it is a concave up, the range must be given by y is greater than or equal to q, or y is an element from q to positive infinity. We include the q. We use the inequality sign greater than or equal to. If it is concave down, it will have a maximum, and the maximum will be at the y value at the turning point, which is our q, and the range will be given by y is less than or equal to q, or it will be given interval notation from negative infinity to q. Now, I want us to quickly try and sketch the graph of f of x. I'll give you 2 minutes to do the sketch. Right, I hope you are done. So to sketch the graph, remember we need our turning point. So from this, we are able to see that our turning point will be given by -1 and 8. We are also able to see that the equation of our axis of symmetry will be given by x is equal to -1. And then we also need our y-intercept. To get our y-intercept, we know that we evaluate our x is equal to 0. So we evaluate f of 0, which will give us 2, 0 plus 1 squared plus 8. Sorry, there's a negative there. And this will give us a value of 6, meaning that will give us 0 and 6 as our y-intercept. To get our x-intercept, we know that we are evaluating f of x is equal to 0, and we are solving the equation -2 x plus 1 squared plus 8 is 0. We can quickly have x plus 1 squared is equal to, when we transpose 8, it becomes -8. We divide by -2, that will give us +4. And from there, we know that this will give us x plus 1 is equal to plus or minus the square root of 4. And this will give our x as -1 plus minus 2. And we are able to get our x as -3, or our x as +1. So we are able to get our x-intercept as -3 and 0. And also we have our 1 and 0. Now, we have our x-intercept, we have our axis of symmetry, we also have our turning point. But there's one thing missing. How do we get the shape? If you check, our A is given as -2, and we know that -2 is less than 0. So our A is less than 0, therefore our graph is going to be concave down like that. So we get the shape. So we indicate our turning point. It will be -1 and 8. We also have our x-intercept. We got it as 0 and 6. We also have our x-intercept as -3 and 0. We also have the other x-intercept as 1 and 0. And then from there, we join our points and we come up with our sketch like that. So please, let's try and make our curves smooth. I know we can't use a ruler there to join the points, otherwise the graph becomes wrong. We have to indicate with arrows there to show that our graph continues. We are able to see the shape of the graph there. So for you to get good marks, you are going to get a mark for the turning point and the x and the y-intercept, as well as for the correct shape. So you will get about 3 marks in an exam for that question. We move on to the next part. What is the equation of the axis of symmetry of F? We have already answered that one. We got it as we got the equation of the axis of symmetry as x is equal to -1. We move on to the next question. I will write it down. X is equal to -1. The domain of F, we are able to see that our graph continues from -infinity to +infinity. Our X is an element of real numbers. The range, because our graph is concave down, it will have a maximum, and therefore we will have our range as y is less than or equal to 8. Or in interval notation, y will be an element from negative infinity to positive 8, like that. Easy one. Now, I'll give you a chance to answer the next question. I will give you are going to determine the intercepts, and then you're going to also determine the turning point, and the next question is sketching. So determine these and sketch. I'll give you 3 minutes. Okay, now we will get the x and the y intercept. I will start with the y intercept because it's easier. Our x is 0, g of 0 becomes negative 6, and I know that this will give me 0 and negative 6. Then to get the x-intercept, I am solving the equation x squared plus x minus 6 is equal to 0. Factorization is easier. I'll have x plus 3, x minus 2 equals to 0. I'll get my x as negative 3 or my x as positive 2. I'll encourage you to always write the x-intercepts as coordinates. You will have your negative 3 and 0, or your 2 and 0. Then we are supposed to determine the turning point of G. Remember, the turning point must have an X value and a Y value. Now, this is a quadratic form. As I indicated, we can use X is equal to negative B over 2A. I'll do the substitution to get my X value at the turning point. It becomes negative. I have substitute my 1. My A is also 1, and this will give me negative half. To get the corresponding Y value at the turning point, let's use our calculators. F of negative half, because our X is negative half, and that will give us negative half squared plus negative half minus 6. Punch the calculator, the answer should come out as negative 25 over 4. From there on, I'm able to determine the coordinates of the turning point. It will be negative half and negative 25 over 4. It makes life easier because you know where to place the point when you are supposed to do the sketch. I will move on to the next question. The next question, we are supposed to sketch the function, but we are short of one information. We have our turning point as negative half and negative 25 over 4. We have our x-intercept as negative 3 and 0. We also have our other x-intercept as 2 and 0. And we have our y-intercept as 0 and negative 6. Our axis of symmetry will be given by x is equal to negative half. Now, let's quickly do the sketch. I will start with the axis of symmetry. X is equal to negative half. I will have the coordinates of the turning point, and I will also have the y-intercept, the x-intercept. My y-intercept came in late, and then from there, I'm left with the shape. If I check my g of x, my a is positive greater than 0, meaning my graph is going to be concave up like that. Then I just join my points and I get my marks. As you can see, that's my g of x. Now, we are able to see the graph of g of x like that. Again, you'll get a mark for the x-intercept, y-intercept, your turning point, as well as the correct shape. Please, your graph must be smooth. Do not use a ruler to join the points. It must be freehand, smooth, and we try to make our curve as smooth as possible. We move on to D, for which values of x is g increasing or decreasing. Now, remember, it's concave up, so it means it will decrease, then increase after the turning point. Let's find out. Our equation of axis of symmetry is negative half, and our x value at the turning point, it's negative half, meaning for x, it will increase. X decrease. Quickly fill in. I'll give you a few seconds to fill in the information there of the solution. I hope you realize that on the left of our axis of symmetry, those values are less than negative half. And we are able to say it will decrease for x less than negative half, and it will increase for x greater than negative half. Now, we know that this sign sometimes confuses some of us. It always opens up to the bigger one and it always points to the smaller one. So we are able to get our solution there. We move on to the next part, the hyperbola function. F of x is equal to a over x plus p plus q. I've illustrated that. I hope you are able to see because we have been doing the hyperbola from grade 10 and we are able to see what can help us to move on. I'll just emphasize on the issue of our equations of the axis of symmetry. That's a special characteristic. Our A affects the shape, and the shape is determined by the asymptotes that we have. If our P is positive, it means our vertical asymptote will be on the negative side of our x-axis, and our horizontal asymptote, if Q is greater than 0, will be positive. We form the 4 quadrants from the asymptotes. And we realize that A also affects orientation. So if A is positive, our graph will be in quadrant 1 and quadrant 3. You will also see that if our A is negative, the arms of our hyperbola will be in quadrant 2 and quadrant 4, as illustrated there. But I want to bring to your attention also that sometimes we can be given a hyperbola equation given as ax plus b over x plus c, something like that. You will then have to move from this form to that form for you to easily manipulate the question. And we use factorization, and we shall learn another method of long division to help us move from what I have up there to the original function of f of x is equal to a over x plus p plus q. And then we are able to see our effects of a, the effects of p, and the effects of q on our graph. Our domain for our hyperbola function, we always have to be careful. X is an element of real numbers because it's a continuous graph, but we should exclude the asymptote. And the range also, we exclude our horizontal asymptote. Y is an element of real numbers, but Y cannot be equal to Q depending on where our horizontal asymptote is at. You will see as we attempt questions. As you can see, those are the different orientations as we change our values of P and Q, and you are able to see that. The equation of the axis of symmetry is also an important aspect when it comes to a hyperbola. We have an equation of the axis of symmetry that has a positive gradient and another one that has a negative gradient. It's illustrated there on how you get the equation of the axis of symmetry, but I also want to bring to your attention that it's always important to give the coordinates of PQ where our asymptotes intersect, because we know that the gradient of the one with a positive gradient will be given by y is equal to x plus c. Then we are also able to substitute the coordinates of P and Q to help us get the equation. And the other equation of axis of symmetry is given by negative x plus c. We substitute and get the equation of our axis of symmetry. Also, it is important to check that sometimes the question can be asked in terms of gradient, or it can be asked about the equation of the axis of symmetry that intersects the curve, and the other equation that does not intersect the curves of the hyperbola. So you should be able to ascertain that if your a is less than 0, and when your a is greater than 0, you should know which one intersects the curves and which one is in between the arms of the hyperbola. I will give you 3 minutes to attempt that question. I know you have been exposed to a hyperbola, therefore we should be able to answer some of these questions without having to get demonstration. Let's quickly get the equation of the asymptotes. We determine the x-intercept, we determine the y-intercept, and then we sketch the hyperbola. I'll give you 2 minutes. Right. I hope it was an easy task. The equations of the asymptotes, we are having our function given in the form a over x plus p plus q. Now, it means the equation of the vertical asymptote will be given by x is equal to positive 3, and our y will be given, the horizontal asymptote will be given by y is equal to 1. 1 mark for each. Determine the x-intercept of f. To get the x-intercept, we know that our f of x is equal to 0, so we are calculating negative 6 over x minus 3 plus 1 is equal to 0. Now, we can rearrange and get negative 6 is equal to negative 1, and we will have x minus 3 on the other side, and this gives us negative 6 is equal to negative x plus 3, and then that will give us negative 9 is equal to negative x. Therefore, our x will be equal to 9, and we get our x-intercept as 9 and 0. Method and answer, you get your 2 marks. We need to determine the y-intercept. To get our y-intercept, we evaluate f of 0, and that will give us negative 6 over 0 minus 3 plus 1. And negative 6 divided by negative 3 will give us positive 2 plus 1. This will give us 3. So our y-intercept will be 0 and 3. So we get our 1 mark for the y-intercept. We move on. Sketch the graph of f. We clearly label the asymptotes and the intercepts with the x's. That's 3 marks. So we will have our horizontal asymptote, and we know it's given by y is equal to 1. We will have our vertical asymptote given by x is equal to 3. And we said our x-intercept was 9 and 0. And our y-intercept was 0 and 3. So we are able to put those points on the Cartesian plane, but we need the shape to help us get the correct graph. So what we need to do, you realize that your a is equal to negative 6 and negative 6 is less than 0. So our a is less than 0. So we know that our function, the arms of the hyperbola, will be in quadrant 2 and 4. And then we are able to indicate the point of intersection of our asymptotes. We have our y-intercept, we have our x-intercept, and then we are able to draw the arms of our graph. So for both asymptotes, we'll get 1 mark. For the x and the y-intercept, also 1 mark. And for the shape, please, we need to be careful when we are drawing the graph of the hyperbola. Make sure that your arrows are not left pointing towards the asymptotes. They should point away, as you can see there. They shouldn't be pointing there, otherwise we'll lose a mark for shape. We move on to the next question. Write down the domain and range for both. For the graph of f, we are writing for both domain and range. 2 each, hence we have 4 marks there. The equations of the axis of symmetry of f, we have 2 marks there. Now, the domain, we know that our x is an element of real numbers, but our x cannot be equal to 3 because x equals to 3 is our vertical asymptote. Our range, so that's our domain. Our range, y is an element of real numbers, but our y cannot be equal to 1 because y equals to 1 is an asymptote. Our graph will never intersect the asymptote. The equations of the axis of symmetry, as indicated, we can take this part and we will get the one with the positive gradient. It will be y is equal to x minus 3 plus 1, giving the equation as y is equal to x minus 2. That is the one that will have a positive gradient. And the equation of the axis of symmetry will have that shape. It means it's the one that is in between the two arms of the hyperbola. It's not intersecting the hyperbola. The other equation of the axis of symmetry will be given by y is equal to negative x minus 3 plus 1. And this will give us negative x plus 3 plus 1. And the equation will be given by y is equal to negative x plus 4. And this is the one that has a negative gradient. So that one will intersect the two arms of our hyperbola in quadrant 2 and quadrant 4. Now, to just demonstrate the other way of getting the equation of the axis of symmetry, as I indicated, I said the one with the positive gradient will be given by y is equal to x plus c. We substitute the coordinates of the point of intersection, which is 3 and 1, of our asymptotes. When our x is 3, our y is 1. So we'll have 3 plus c, and we get our c as negative 2. Then we easily get our equation as x minus 2. You can do the other one using this method. You should also be able to get the equation as negative x plus 4. So you are able to see the equations of the axis of symmetry. The one with a negative gradient is green, and the one with a positive gradient is red. I've given you the equations there. Now we want to look at the exponential function. It's given by f of x is equal to a times b to the power x plus q. We can have b equal to greater than 0, but b cannot be equal to 1. Remember, we said our b can be greater than 1, or our b can be a fraction between 0 and 1, as you can see there. The a affects the orientation of the graph. If you check, if our a is greater than 0 and our b is greater than 1, it's an increasing function. As you can see, it has an asymptote there, and our graph will be increasing like that. If our b is a fraction, our graph becomes a decreasing function. As your x values are increasing, your y values are decreasing, but there is always an asymptote there. If a is less than 0, you reflect the graph about the line of symmetry that you are having there, and you will have the graph. As you can see, that one was increasing. If you have your a as negative, the function becomes a decreasing one. And if you have your b as a fraction, you can see that your function is decreasing, but if you change the value of a, it means the graph becomes increasing, and we should be able to see that from our graphs. We know that y is equal to q is the equation of the horizontal asymptote. This has only one horizontal asymptote, and we know that a will affect the stretch. You will see as we move along. So it has only one horizontal asymptote. The equation is given by that. Our q can be positive or negative. We substitute accordingly. The exponential curve has no axis of symmetry. We are able to see that. There is no restriction on the domain of the exponential graph. So our domain x is an element of real numbers. X is an element from negative infinity to positive infinity range. It's given by a greater than. If a is greater than 0, the range will be above the asymptote. You will see. So it's from q, whatever we have as our asymptote, and we do not include the value of q up to positive infinity. If a is less, we are able to see what is happening there. And then I would ask you to quickly sketch the graph of f of x. I'll give you 2 minutes to do the sketch. Right. I hope we're able to sketch the graph. Now, for us to sketch the graph, we should get our x-intercept, we should get our y-intercept. If it's there, we should get our asymptotes. So, if you check this one, we know that we can have our y is equal to -2. That one becomes our horizontal asymptote. And then we are able to get our x-intercept by making our f of x equal to 0. And this will give us 2 to the power x plus 2 minus 2 is equal to 0. We get 2 to the power x plus 2 is equal to 2. So our knowledge of solving exponential equations is being used here. And here we know that we have a silent exponent of 1. Bases are the same. We equate the exponents. We'll get x plus 2 is equal to 1. We get our x as -1. And therefore our x-intercept would be -1 and 0. We also need our y-intercept. Our y-intercept, we know that our x must be equal to 0. We evaluate f of 0, and that gives us 2 to the power 0 plus 2 minus 2. 2 squared will give us 4 minus 2, meaning our f of 0 will be equal to 2. So we'll have our y-intercept as 0 and 2. The other thing that we need is the shape. Our graph, because we have a silent 1 there as the coefficient of 2, we are saying our a is equal to 1 and a is greater than 0. Our function will be increasing. It will have a shape like that. Now, let's quickly sketch. We have our asymptote, y is equal to -2. We have our y-intercept, 0 and 2. We have our x-intercept as -1 and 0. Then our function is increasing. We join the points. So you'll get 1 mark for the asymptote. You get a mark for the x and y-intercept. And you get a mark for the shape, 3 marks. Let's answer the other questions. Write down the equation of the asymptote of f. We have already given it. It's y is equal to -2. The domain and range. The domain, you are able to see x is an element of real numbers, and the range becomes y is greater than -2, because our graph is not defined below our horizontal asymptote. Now we have that function, but I'll jump this one. Let's quickly answer question 5 as an activity. I will give you 10 minutes to try and answer what you can. Right. I hope you have attempted to solve what you can. Now, in most cases, our questions on functions come combined. You will find out that you'll be given a question like this. To determine our f of negative 3, we know that f of negative 3 becomes negative 3 over negative 3 plus 2 plus 1. And we know that negative 3 plus 2 will give us negative 1, and this will give us negative 3 over negative 1 plus 1, and this will give us negative 3 divided by negative 1 gives us positive 3 plus 1, that gives us 4. You are done. You get your mark. We are supposed to determine x. If g of x is equal to 4, it means you are solving the equation 2 to the power negative x minus 4. In place of gx, you substitute 4. You will get 2 to the power negative x is equal to 8. And then from there, 2 to the power negative x is equal to 2 to the power 3. And we get negative x as equal to 3. Therefore, our x will be equal to negative 3. We are done. We get our 2 marks. We move on to 5.3. The asymptotes of f, we will get our x as negative 2 and our y will be positive 1. The range for the graph of g, our graph of g is an exponential function. Therefore, our range will be y is greater than negative 4, because y equal to negative 4 is our asymptote. 5.5, the coordinates, the x and the y coordinate intercepts of the graph of f. To get the x-intercept, we know what to do. We are solving the equation negative 3 over x plus 2. I will be first negative 1. We know it's equal to 0. We get negative 3 is equal to negative 1. X plus 2. That will give us negative 3 is equal to negative x minus 2. And we get our negative 1 is equal to negative x, and we get our x as 1, meaning it will be 1 and 0. To get our y-intercept, we are evaluating f of 0, and that will give us negative 3 over 0 plus 2 plus 1. And we have our f of 0 as negative 3 over 2 plus 1, and that will give our f of 0 as negative half. And then from there, we know that it will be 0 and negative half. We should therefore be able to sketch, we are supposed to determine the equation of the axis of symmetry. It will be given by y is equal to negative x plus 2 plus 1, and that will give us our y is equal to negative x minus 2 plus 1, giving us y is equal to negative x minus 1. Now, the next question, we are supposed to sketch the two graphs on the same system of axes. So we shall use the information that we have learned to do the sketch, and due to time, I will not be able to sketch that one. You will sketch it on your own because you have all the information to help you sketch the graph. Here is our homework. You can take a screenshot of it, or you can now work on that homework, as it will help you answer the questions there, the type of questions that are asked under this topic. I'll give you 1 minute to copy the homework or to take a screenshot of the homework. That's the first question for the homework. I'll give you another one just now. Thank you. I like 7.2 more. I hope you'll get the correct sketch. Here is another one that you can quickly copy and work with. You will practice our hyperbola there. I hope you have managed to copy or take a screenshot of that question. Now, after doing all these activities, we were able to realize something. If our function is a linear one, ax plus q, you have realized that the domain is x is an element of real numbers and your range y is an element of real numbers. If we have a hyperbola, we know that our domain x is an element of real numbers, but we exclude our vertical asymptote. Our range also y is an element of real numbers, but we exclude our horizontal asymptote. And then our quadratic function, our domain is x is an element of real numbers. Our range, we know that if our a is positive, it is greater than the y value at the turning point. I hope you are able to see that. And our exponential function, you are able to also see our domain and also our range. You will also realize that for our functions, our linear function, it has no turning points, it has no asymptotes, it has no axis of symmetry, but our hyperbola, it has a vertical asymptote given by that equation, it has a horizontal asymptote, it has also the equation of the axis of symmetry given there. Our parabola has a turning point and we are able to get the coordinates of the turning point as given there. And it has no asymptotes, and we know that the equation of the axis of symmetry, it's either given by negative b over 2a or by x is equal to negative p, and then the exponential function only has a horizontal asymptote. To get our x-intercept, we let our y be 0 or our f of x or g of x be 0, and to get our y-intercept, we let our x be 0. So in summary, we must be able to use the function notation to solve problems involving functions. The effects of the parameters we have summarized them and must be used to help us sketch the graphs. To get the y-intercept, I have said that one. To get our y-intercept, we evaluate f of 0, we know that. So the function can be described as increasing or decreasing depending on the shape and orientation of that particular function. So in summary, we have concentrated more. We must always know our domain and range when we are answering these or sketching these graphs. We know how to get the intercepts with the axis. We know how to get the turning points. We must know how to get the minima and the maxima. And we should know and indicate our asymptotes. We should be able to get the correct shape and symmetry, and we should be able to know the intervals on which the function increases or decreases. Thank you so much for watching. Have a good day, and please remember to sanitize and wear your mask. Remember, we need you to write this exam at the end of the year, and you are aware that our COVID numbers are increasing. Let's keep safe and maintain our social distance. Thank you.